So today we're going to start a new, yet another, what seems like another gas law called the ideal gas law. So we've done actually several different gas laws. We had Boyle's law, Charles' law, Gay-Lussac's law, Avogadro's law. All put together, that's the combined gas law. We're going to be using that to come up with another gas law called the ideal gas equation. That's what it says here. Also just known as the ideal gas law. And so we had several gas laws. Again, the first one, Boyle's law, Charles' law, and Avogadro's law. The first three, first one, Boyle's law. And this is not in any specific order, but I just have them in this order right here. First one, Boyle's law, volume is proportional. That's this little fish-like symbol looks like, it's a Greek letter alpha. But volume is proportional to 1 over the pressure. It's inversely proportional. Again, what that means is one goes up, the other one goes down. Okay, as volume goes up, pressure goes down. As pressure goes up, volume goes down. It's inversely proportional, just like a seesaw. Charles' law is a relationship between volume and temperature, and this is directly proportional. As temperature goes up, the volume goes up. Temperature goes down, the volume goes down. Volume goes down, temperature goes down. Okay. Avogadro's law, volume is proportional to N. N stands for the number of moles. N stands for moles. Why in the world is N moles? Because M is already taken for, capital M is already taken for molarity. There's a lowercase m stands for molality. Also units of M mass. So we had to just come up with another symbol. N stands for moles. Okay. So N stands for moles in this. Volume is proportional to moles. As the number of moles of gas goes up, the volume increases. As the number of moles of gas goes down, the volume decreases. They're directly proportional. By the way, similar to Boyle's law, this is assuming constant number of moles and temperature. Charles' law, number of moles and pressure. Avogadro's law, pressure and temperature. So volume is proportional to 1 over pressure. Volume is proportional to temperature. Volume is proportional to N, the number of moles. So it's proportional T, N, and 1 over P. So if I put them together, that's the same as volume is proportional N, T, divided by P. Volume is proportional to N times T divided by P. What does proportional mean? That means it's equal to a constant times that thing. If I say A is proportional to B, that means A is equal to some sort of constant times B. If I say X is proportional to Y, that means X is equal to some sort of constant times Y. Maybe you start off somewhere like Y equals mx plus b. You might have seen something like that in math. Y is equal to some sort of constant times x plus maybe something else, plus b. Okay, but V is proportional to nt over p. V is equal to some sort of constant times nt over p. Rewritten, V is equal to some sort of constant times nt over p. We are going to call the constant in this chapter R. R is also known as the gas, what's it called? Just the gas constant. R is called the gas constant. There will be a number associated with this. That's going to be in the next slide. Not yet. But V is equal to some sort of constant. We'll call it R times NT over P. Volume is equal to some sort of constant times the number of moles of gas times its temperature over pressure. Oh, quick reminder, temperature always in kelvins. Temperature always in kelvins. In this chapter, temperature will always be measured in kelvins. Okay, so volume is equal to a constant called the gas constant. Okay, that's easy. This whole chapter is on gases. So the gas constant times the number of moles of gas times the Kelvin temperature, all divided by the pressure. Rearranging that equation, it's sometimes written just like this. PV equals nRT. The pressure times volume, multiply both sides by P. The pressure times volume equals the number of moles, N, times R times T, where R is the gas constant. Again, we'll get to what the R is in the next slide. It's just a constant right now. But the pressure times volume of a gas is equal to number of moles of gas times a constant times temperature. This equation is also commonly known as the ideal gas equation, or just commonly the ideal gas law. Okay, so you'll hear that a lot. The ideal gas law, PV equals nRT. 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 Okay, so you're going to have to know the ideal gas. Normally, you would have to know this ideal gas law. If this were AP Chem, you would actually have to have all these equations memorized. Actually, even in this class, if this was regular school and not online, you would have to have all these equations memorized. And like I would give you the tests, and you bring a calculator and nothing else. You would have to kind of know everything. The equations necessarily, like Boyle's law, Charles' law. You wouldn't need to know the name of it, but you need to know how to use the equations. Okay, so here's another thing you would have to know. The conditions 0 degrees Celsius and 1 atmosphere are called standard temperature and pressure, or STP for short. 0 degrees Celsius, 1 atmosphere is called standard temperature, or STP for short. 0 degrees Celsius, 1 atmosphere is STP. 0 degrees Celsius, 1 atmosphere is called STP. 0 degrees Celsius, 1 atmosphere is called STP. Yes, I'm repeating it a lot. 0 degrees Celsius, 1 atmosphere is called STP. It's something that you should know. When we say, hey, something's at standard temperature, that is 0 degrees Celsius. Not room temperature. Standard temperature, by definition, is 0 degrees Celsius. Standard pressure, by definition, is 1 atmosphere. Together, standard temperature and pressure, or STP, is 0 degrees Celsius, 1 atmosphere. A term that you should have to know. Again, definition of 1 atmosphere, standard pressure, that is pressure at sea level. In LA, we're pretty much at sea level. If you want to be technical, fine, go down to the beach, okay? That's at the beach, that is 1 atmosphere. But, close enough. The pressure at sea level, atmospheric the pressure of our air pushing down on us, is 1 atmosphere in LA for the most part. Unless you just so happen to live like in Mammoth or something, or wherever, somewhere higher up. In LA, we're pretty much, at sea level, 1 atmosphere. Okay, there's also one thing that we've know that after multiple experiments, we found that one mole of gas at STP always occupies the same volume. 1 mole of any gas. So if you had 1 mole of gas, which, reminder from back in chapters, 6.022 times 10 to the 23rd molecules. If you had 1 mole of gas, any gas, you pick the gas, 1 mole of any gas occupies a volume of 22.414 liters. So 1 mole of any gas, experiments have shown that at STP, 1 mole of an ideal gas occupies a volume of 22.4, I said 22.4, here's 5 sig figs, 22.414 liters. So 1 mole of any gas, how big is that? Well, here's a basketball, okay, for reference of size. Obviously bigger than a basketball, about that size. 1 mole of any gas at STP is 22.414 liters. Not a number you have to memorize, but it's just, we know that if you took any gas, hydrogen gas, oxygen gas, helium, carbon dioxide, you take 1 mole of that gas at 0 degrees Celsius in 1 atmosphere, it will have a volume of 22.414 liters. Okay, so what? If we know that, and I know the equation that PV equals nRT, right? That's the ideal gas law. If I solve for R algebraically, R is equal to, divide both sides by NT, R is equal to PV over NT. Okay, so why do we care if R is equal to PV over NT? Well, again, 1 mole of any gas at STP is 22.414 liters. 1 mole of any gas at STP is 22.414 liters. Well, if N equals 1 mole, the temperature at STP is 0 degrees Celsius or 273 kelvins. The pressure is 1 atmosphere, because that's what STP stands for. The volume is 22.414 liters. I can plug that in. Pressure, 1 atmosphere. Volume, 22.414 liters. N, number of moles, 1 mole. Temperature, in kelvins, 273.15 kelvins. I now know what R is. R, type that all in a calculator, 0.082057. The units are liters, atmospheres, divided by moles, kelvins. 0.082, lots of times we round this 0.0821, to 3 sig figs, but here this is, 5 sig figs. 0.0821, 3 sig figs is usually what we do. 0.0821 liters atmospheres per mole Kelvin. R, the gas constant, is 0.0821 liters atmospheres per mole Kelvin. That's what R is. So that's the gas constant in PV equals nRT. In other words, the pressure times volume of a gas is equal to the number of moles of gas you have times R. This is R, 0.0821 liters atmospheres per mole Kelvin times its temperature. So now I have 4 variables, not 5, because R is kind of, well, we now know what it is. It's kind of like if you had some equation like area is equal to pi r squared. What's pi? It's a number, 3.14. I know there's more digits, but 3.14 is what is pi. PV equals nRT. What's R? R is 0.0821 liters atmospheres per mole Kelvin. That's what R is. So that is R in the gas law's equation, ideal gas law. We're now going to use that in a sample question. Here's a sample problem. And so in this sample problem, it says, what is the volume in liters occupied by 49.8 grams of HCl at STP? First of all, what is HCl? In this chapter, this is gas laws. It's a gas. What kind of gas? Who cares? Well, it's HCl gas, but we are assuming that this is gases, okay? Gas laws only applies for gases. You can't use gas laws on liquids or solids. It only applies for gases. So we're assuming that it's a gas. So you don't know what HCl is? Who cares? It's a gas. Okay, for this chapter at least. Also, it tells you, it's the STP, meaning we only have pressures of gases anyways. Okay, so I know the equation I have to use. It's this. PV equals nRT. Pressure times volume equals N, the number of moles, times R, gas constant, times temperature. What am I trying to solve for? V, volume. What is the volume? So solving for V is equal to nRT over P. Okay, how do I do that? Divide both sides by P. I am doing it in variable form first. So the volume of the gas is equal to N, the number of moles, times R times T over P. Well, I just need to know what nRT over P is, PR, those 4 variables, and I can find a volume. N stands for the number of moles. Do I know the number of moles of gas? Yes and no. I know it was 49.8 grams. Okay. Well, if I know the number of grams of gas, can I change grams to moles? Okay. Of course I can. Also, I need to know R, but I already know R. Let me go back for a second. R is equal to 0.0821 liters atmospheres per mole Kelvin. You know R. So we know what R is. Temperature. Do I not know what the temperature is? Of course, this is a STP. STP means 0 degrees Celsius, and the pressure is 1 atmosphere. So I know these things. I know it's 0 degrees Celsius and 1 atmosphere. It says it's STP. The definition of STP is 0 degrees Celsius, which is fine, 273 kelvins. Temperature always has to be in kelvins, and 1 atmosphere. I know T, I know P, I know R. I just need to find N. Well, I know how to find N. N stands for number of moles. It's not exactly given, but I kind of can calculate it. I have 49.8 grams of HCl. 49.8 grams of HCl. If I want to change that to moles, change grams to moles by, I need to find a molar mass. And I know how to find molar mass. I need a periodic table. To find molar mass, I need to find how much does 1 mole HCl weighs. 1 mole hydrogen on the periodic table is 1.01. Chlorine, I believe, is 35.45, something like that. This is just from memory. Adding that up, that is 36.45. 1 mole HCl is 36.45 grams. So 49.8 grams, grams and grams cancel. Oops, not that yet. Grams and grams cancel. And I have moles, 1.37 moles. Now I know N, 1.37 moles. I know R is on the last slide, 0.0821 liters atmosphere per mole Kelvin. I know T, temperature, 273.15 kelvins. I know P, pressure, 1 atmosphere. Plug it all in. N, 1.37 moles. This is R, 0.0821 liters atmospheres per mole Kelvin. The temperature, right there, 273.15 kelvins. And the pressure, 1 atmosphere. If I type this all in a calculator, I should get, well, actually even before that, notice units moles and moles cancel. Notice kelvins and kelvins cancel. Atmospheres in the numerator and denominator cancel. The only unit that does not cancel are liters. Isn't the question, what's the volume in liters? I'm trying to find liters. So the answer is going to be whatever 1.37 times 0.0821 times 273.15. So type that in a calculator. What is 1.37 times 0.0821 times 273.15? You should have gotten 30.6 sig figs, 30.6 liters. Okay, so that's how I use the ideal gas law.